So today I will be talking about how I analyzed an object undergoing a change in motion in order to determine my unknown force acting upon it. So this is my problem. I found some wood while camping in the snow, and I want to be able to push the wood across a frozen pond made of ice. But the weather is bad, so I like to move at least 2 meters per second after 5 seconds of moving. The mass of the wood is 10 kilograms, and I need to figure out the force I need to put in order to push the wood that way. So my first step is to create a free body diagram. The things I know are that I have 4 different types of forces acting upon it. I have gravity and its coupled normal force, as well as the push of my force and the friction acting against that. And so I drew a free body diagram. It looks like this, in which I have gravity and the normal force equaling each other because the wood is not lifting up or anything, and hopefully the push is stronger than the force of friction, therefore I can actually get to move at 2 meters per second. The next step is to calculate Fnet. So because my object is moving in the right direction, I am probably not going to have a 0 Fnet, and actually I'll have a positive Fnet. So the different things I know to calculate this is that the wood is 10 kilograms, and I want to be moving at 2 meters per second as my final velocity. So I calculated that using our dp dt equation, and I found that my net force is 400 in the x direction. So I'll be moving to the right. And then my last step was to do some force analysis. So I know that the addition of all my forces will add up to be 400. And so what I did was I set them all to 400, and then I calculated using that. So I'm going to start with the y component because that's the easiest to explain. What I did was multiply my force of gravity times 10 and then set those equal to each other, the y component, so that they equal 0. The next was to figure out the force of friction. So I multiplied my normal force by my mu, which is 0.05 for ice on wood, and then I got negative 4.9 newtons, sorry. And in order for all of this to equal 4, I figured out that I have to be pushing at 8.9 newtons in order to move in the positive 4 direction.